Hello, I'm Camille Clayton, and thanks for coming to today's talk about SRE, Site Reliability Engineering. We'll be diving into how my team is using as a backbone for our operational practices, discussing one of our major technical outputs, and how virtual fire can bring inspiration to a team. Throughout this, I have a deep love for system design, distributed and serverless systems as a specialty, and we're jumping into how we built a new serverless system and the team that made it possible. Before we jump in, here's a little bit about me. I am an operations-focused team lead with 8 years of IT experience, and about half that time has been on government supporting work. I live in the DC area, have been working for Pluribus Digital for about 18 months, and have been involved with Women Who Code DC since 2018, and I started there as a director in late 2020. There, I give a monthly talk about DevOps-focused concepts, and I'll share a link to our next meetup in the chat, where we'll be diving into Elasticsearch. Also, this is my second DevOps ACC where I've had the pleasure of giving a talk, and thankfully you all have tuned in today. With that, I'll be answering questions below in the chat. If you have any, feel free to add them to the discussion. So to set the stage, before we dive into those technical details, I want to paint the picture of what we were dealing with back in late April of 2020. So during that time period, I joined Pluribus Digital as they came into a contract supporting a client that was heavily affected by COVID-19. The switch to remote was hard as we had an offboarding contract team who had been fully co-located, and we were onboarding our teams fully remote. In short, chaotic was an understatement. Hitting the ground on this contract, our systems, even though lightly in use, were mission critical. Uptime was super important, and they were suffering. These systems were at the tail end of a hybrid to fully cloud migration, and lots of work was in flight and incomplete. As team members from the prior contract offboarded, their knowledge was being lost by the day, and everyone was getting anxious. To top it all off, alert fatigue was high. The system had a lot of alerts configured, but they were highly distributed amongst teams. There were numerous duplicate alerts, and there was no central game plan for how to deal with an alert when they came. And so as the situation got rougher, as we got further in, as we got into the early summer and COVID restrictions eased up, the systems began failing under the lightest of user workloads. It felt like they may have been built with hay and a stiff wind could blow them over. These system failures then led to days-long conference calls between internal and external teams, frustrated stakeholders, engineers, and there was a never-ending sense of panic as you waited for the next undocumented and fragile system to pop an error. And so as we sat and we talked and we had issues and discussions, we started thinking about how we could get through this situation. As part of a government contract, you have intentions and keys and guidelines. And one of our main keys was that we were focusing on DevSecops as a key developmental practice. This concept involves shifting left, where you integrate security as a key and automated practice throughout your development lifecycle. Though, as we're getting into the middle of summer of 2020, one of our deficits was we only had one security officer. And as we had been onboarded initially, we're struggling as a project to manage, security patching for our classical VM-based systems. The previous team had been much larger, about twice as large as we'd eventually get, and they had performed this work fully manually. They just weekly, monthly, year after year logged into every single system. We're talking at that point of hundreds of systems, and got the work done. But we've been on this contract now a few months, and we're about 40 persons strong on a team that's going to grow to around 85 team members. We just couldn't sustain that. And so as someone with an operational background, having made some early wins in resolving system issues, I was then picked to be a team lead for a small operations team. This role would include being the central technical point for security implementation and analysis. The contract leadership would end up assigning me 4 engineers, and they gave me about a sprint's lead time to think about how to best utilize and implement this team. I took this to heart and sat down and chatted with each of the other engineers during that 10 or so days, and I produced 2 key documents. And the first document would be an output for how our team would be built, what our overall skills were, and what our goals were for the near and long term. Important among these, was discussing the fact that we had general experience as backend engineers, and we had deep knowledge in areas such as SQL reporting and database management, automation platforms in Jenkins and Ansible, and operating system support. Tend to highlight a few. And with this intention setting, we also set foundations for our culture as a team by encouraging important things to be written down, defaulting to open conversation and decision-making, and striving to cross-train as we grew as a team. And then that second document I created broke out what each engineer, including myself, had skills on, sort of a roster, a way to look at it, like if you're looking at like a fancy football team or a Pokemon team, depending on what kind of engineering nerd you are. But this roster would be really important when there was an emergency. We could quickly figure out who had and who didn't have experiences with the system. As one of my takeaways from the troubleshooting bridges was we often didn't have the right person on the call for long periods of time, which is prolonged outages. There were some times where I could end up resolving a situation in 10 minutes, but it took 4 or 5 hours for someone to be like, let's try Camille. And we had issues with a number of different areas as we had a very wide and sort of shallow project at that point. And the other main thing that came during the formation period of this operations team was after we've been working together for a few sprints, I had everyone take an hour and a half, and we each took turns discussing which things flustered us the most. And we took that list and we started, narrowing it down throughout that time, and we thought about which ones could be resolved. And so we took notes on that, and I worked with our Scrum Master who joined in the interim, and we developed a backlog of items to resolve. And this list we would eventually turn into Jira stories and epics. And so for an ops team, if you work with most ops teams, they generally don't work in traditional sprints development cycles. I've previously done Scrum, but we were doing more akin to Kanban initially, and then later we were working in a safe agile method along with program increments. For an ops team that was working side by side with developers, creating the backlog let us show visibly both the work we cared about and the work we were actively accomplishing. Even if it wasn't something a stakeholder could easily visualize or something we could easily demo, this ended up being a huge trust builder for our team and for the client. We've continued this method of backlog building every quarter since. And so I've talked a good bit about the team, but how does SRE come into play for this? So we had 9 development teams that we were supporting, and each has had unique and overlapping issues. And by the time we hit September 2020, my team had grown to include 2 additional engineers and a business-focused Scrum Master as a co-lead. This gave us enough room to tackle a combination of big and small issues. And those smaller issues are where our implementation of our SRE model was very impactful. If you haven't encountered SRE in the wild, it's a method for DevOps at scale that was popularized by Google. They have a series of free books and documents at sre.google.com, and their first book, Site Reliability Engineering, hit home to me in the mid-2010s when I was working as a sysadmin. Google's idea of an engineer in this model is one who's good at automating, problem solving, possibly a bit lazy, and one who might get bored. Where this type of engineer succeeds is at the team and the problem level. So if you have a team of these engineers, they aren't necessarily dedicated to a specific development team. They're not necessarily dedicated to the SRE team, but where they come in are effective as engineers is a slack to a team that's both stretched with their day-to-day responsibilities and is facing active production issues. So Google Site Reliability Engineer will rotate through various dev teams between every 1 to 3 months, which is enough time to sit with the team daily, gain understanding of their environment and the problems they're encountering, and to develop ideas and solutions that they and the team can implement to build a more robust and stable application. The end goal being that when the SRE rotates out, that the application is running better than before they arrived, and the team then is no longer running over capacity. So to kick off this team, this practice, the engineers that made up our team had come from being part of active development and development support backgrounds. And we focused out then on delegating each team member initially to dev teams at about 60% of the time, and 40% of their time, they'd be focused on project-wide operational tasks. Initially, our big project-wide task was on automation of security and feature patching, which involved configuration of Ansible Tower for our environment and working to train and test and then to automate this for multiple platforms as we have various flavors of Linux and Windows Server to support. After that, we were internally, we felt we were succeeding at this tagging off model, and the engineers were familiarizing themselves with the various dev stacks, but we were struggling daily with alerting. The issue was that alerts came from emails, but if no one was sitting at their desk, or if it came after hours, if the team was just really busy that day, they'd get missed. And we had dealt with the initial just flood in the summer and really cut down and stripped back the amount of alerts, centralize them. Dev teams could still get specific app alerts. We made sure the operations team was on every alert. We'd really cleaned up the stack, but we were still failing to catch alerts. And so I sat down one weekend and I came up with an idea. I had used a paging system before called Opsgenie. But I also knew with COVID restrictions that our budget was very tight on this contract. So with that in mind, a budget of effectively $0, what did I have access to? What could I build with? What could I think about? And so, everyone who's working in cloud has probably created a free account with AWS or one with Google or Azure. You probably have some sort of cloud account to test on. And our client had an AWS account. And so if I could build something my own, little private one, and what I was willing to put on, a credit card, which was not very much, I could take that and move it forward. And so that was sort of what I thought about that weekend. What is the simplest version of an on-call system? And to me, the simplest version is just one where a user can call a single number, save that number in their phone, call it when there's an emergency, and it goes directly to someone's phone, someone's hand. And whether this phone is passed in a traditional system or if it's going to get virtually forwarded, as in our case, it doesn't really matter to the user. And, even if outside of COVID, this team was designed to be a remote first and focused team. My operation team was spread across the entire East Coast, and the contract as a whole, we have engineers from as far north as Maine to as far west and south as San Diego. And so thinking about tooling that would work remote was really crucial to long-term success for this. Now, where the system of one phone number to one recipient is weak is what happens when that person doesn't pick up the phone. They don't answer a call. And so thinking back to that Google SRE workbook, it's a series of essays, and more than one talk about this and how to design effective escalation and sustainable on-call rotations. And key to that is having on-call backups and really driving in mind blameless postmortems. We've all left our phone in the car. We've all forgotten to turn do not disturb off. These things are common, and so you just make a system where it doesn't matter that much, and it makes it healthier mentally dealing with stressful situations. And so I went back to my personal AWS account and I started playing around with a tool that I knew existed called Amazon Connect. And by the end of a Saturday, I'd implemented the first version that would let a user know they were reaching out to an engineer. If that person didn't pick up, it would route to a secondary contact. And I got it working with 2 phones at my house. And then, I sat down the following day and I iterated, and reading the documentation, I realized I could create a Lambda function that could be invoked by Connect, but it needed data. And I knew about DynamoDB. I used it a little bit in training for one of my certs. And so I launched a DynamoDB to create a really simple schema that just had a phone number and a name, and pop the phones I had at my house in there, and got the Lambda function working where as the workflow goes through, instead of having a hard-coded value, it now has a function that gets invoked when a user calls that number, grabs that data and has it ready, and Connect is able to have a fairly simple variable system that slides into. You can see how this works from left to right in my V1 design diagram here. You can see the user calls into that number is going to stay permanent, and there's a little bit of workflow, and then it gets to a phone. And this all happens fairly quickly. It takes maybe about 10 seconds overall, to get the user to call Amazon Connect, picks up on the first ring. They're going to get that immediate IVR voice response from the Amazon Alexa system. And then while Alexa is talking, it's getting the data calls processing and it's figuring out who to call. If no one picks up, if the first two engineers in this system, in this basic system, don't pick up, Alexa is actually going to take a voicemail, render the speech into text, and create a transcript, and they'll email that transcript out. So even if that second person doesn't get it, it's going to go to a distribution list. It'll hit all 9 of the engineers on our team, as well as some of the managers on the contract. And so there's just a better chance, a wider chance of the alert getting out to anyone on our team with this version. And so after that first weekend, I started discussing this design with my colleagues at Pluribus Digital. I ended up talking a good bit with our CTO, now CDO, Ben Morris, and we ran through ideas of how to pitch this to the client, estimate costs, and what were future insights. As I come in with a real DIY mindset, the pricing on this was pretty low. I estimated even at a fairly high volume of calls, say we were getting 4 pages a week, it would cost about $15 a month to run. And so having these discussions, and not just having them with my internal team, but also feeling confident and being able to communicate back to sort of our central headquarters, it really helped me know I could create solutions, have ideas, and know this would all work in this remote fashion. This was my first job where I was fully remote. I had previously done, working 2 or 3 days a week from home, but it was definitely a leap to go fully remote, and I've thoroughly enjoyed it. And so rolling forward, we had a few more weeks of tweaking. We developed a small presentation with my colleague, Victoria Guido. You may have heard her spoke. She was the host of the previous panel earlier today, and we gave it a first run then with our internal contract, technical leadership. And they liked it, but there was a strong worry that this would be a distraction. And so I took that feedback and we thought a bit, and we had some one-on-ones with some of the leadership, and we devised a plan to build out a version. If we could get client approval, and if we could implement it as a low priority work in sprints. So, if we had anything in our sprint board, it came first. And that was something I felt we could reconcile. And I'll talk a bit about that more as we go through. And so as we got further in, we started working with the client. We had preliminary approval. That first pitch went really well, as it seemed from both a cost and time level that it was going to be a win. After discussion further up the chain, there were concerns from a security and data logging, communication tracking. What would happen on a phone call couldn't necessarily be monitored. And so we went back to the drawing board. And so we worked closely with our client to engineer a solution. And we came up with SMS, text messaging, as a safe medium, as we'd be able to log 100% of our communications. And as we had a large body of successful alerting, we just needed to get it to agents. Instead of thinking about it as a system where users could call, this is now just a system where alerting will actually reach the engineers who are on call. And so working backwards, we dove into what we had. We looked at the version 1, we tried to figure out what was usable and what wasn't from the solution. The first thing out was Amazon Connect, and in its place came Pinpoint. Pinpoint's a really cool service. It sits somewhere between Connect and simple notification service. It allows for a dedicated phone number, so engineers can save that number and they can set it to bypass Do Not Disturb. And what it does is it allows for handling of responses from engineers in a way that like Connect couldn't. This system will allow you to acknowledge or to escalate. It has a few other little functionalities that are built in. If you tell it stop, it'll never text you again. Those kind of things are there for legal compliance. But it's been really easy to build and iterate ideas on. And keeping in this, working towards a high state of effort to result, we kept DynamoDB, but we expanded on its functionality, and we developed a schema that allows it to track event state for messages delivered through another tool that we added, API Gateway. And so I'll pull this up here. We set up API Gateway and we tested it with multiple tools, including New Relic, Splunk, and CloudWatch that's coming from the far left. And we were also able to send out custom messages using API Gateway and webhooks to Microsoft Teams, which allowed us to validate our changes. We were having it sort of be almost as an echo tool. Every time an alert comes in, it also goes to another channel, so we can validate that if we get a text that exists in the Teams, and if somebody's on a computer, they'll see the message as well. And we also put this in a place where the client could easily see, so they could see these iterations and they could see if there's an active alert. And so after about a quarter of a year of work, we provided a proof of concept demo, and we gained approval to hook it into production. And so with that, a few days after we went live, it was a couple of weeks after we got the approval, we tested a bit more in state before we went into production. But after we went live, we got our first system alert. An engineer was able to handle it quickly without bringing up a conference bridge. They, got it handled in 10 minutes on a Saturday, and I had seen it, poking around on a Sunday doing something. But we didn't have a conversation about it till Monday. It felt very good. The team felt empowered, and they knew the tool worked. And so that's really the joy in it. It's working with this team and now this development process. Our operations team bonded. We wanted to work in a remote and asynchronous fashion. We find ways to meet up at regular intervals for joint working sessions. This is how we wrote and got through roadblocks really consistently, where we would meet once or twice a month for 2 hours, either in pair programming or group discussions. And one thing we found as a team was, we had GitHub at this role, but GitHub was unknown to some of the team. And we really worked to fine tune that process as the code base grew. My initial proof of concept had a few hundred lines of code, and the current version has probably a couple thousand, if not, leaning towards 5,000 at this point. We've consistently then booked time to write documentation. And this is the most important thing that's really, come out of this process. As some sprints just, weren't able to allocate any time to making major progress. But having those up-to-date documentation allows us to keep track of completed versus outstanding work. And, it lets us know what's lacking. If there's a section where it's like to do, you can easily come and be like, aha, this is where we're going. And, we really shared in the design process together. On top of that, one of those key things that came out was dog fooding. So as our team was developing this app, we became the first to use it. This led to a lot of realizations, insights, and quickly finding bugs. We used it during that 3-4 months for that proof of concept demo. We had it on non-prod, and so we were alerting on non-prod events. And so you could see, hey, this message is malformatted, or oh, it doesn't like, if it has, say, like a percentage sign, some sort of case setting. But it also came to better ideas to handle things like escalation. We've had a number of iterations on our escalation path. But if we weren't using it, if we were just building it and then waiting for approval, we wouldn't have seen these things. And so I'd highly recommend, if you can find a way as a development team to use an app internally, even if you have to develop an extra feature pathway, this is going to enable your teams to see defects sooner and build more robust versions faster. Your team will want to use good software, And so by forcing them to use a bit of bad software, they're much more likely to build better software. And so thinking about good software, our team is currently working on the next iteration of the app. The goal in mind is that it can support on-call rotations for other developers and development teams in our programs. With 9 teams, we've had to really expand how our escalation of the app works, and we're rethinking our data model and schemas. And we're really excited to, get the app into some of the development team's hands by the end of the year, if not, early winter by the latest. And, so thinking about like the larger outcomes, our operations team is much happier. Since we've gotten the CAP on-call system in production, we've had 3 systems outages, and all have been responded by an engineer and were able to be remediated. At the worst point, when we were talking about the middle of last summer, we were having 4 outages a week for unfortunately more than a few weeks. The developers are also happier. They've seen a decrease in false alerts, an increase in system stability, and they have to investigate less on triage and remediation. If a system crashes and you go through a post-mortem process and it's a bug in the system, and we had quite a bit of them, the developers end up with a lot more work, and that work tends to be lower value but higher priority. And anything you were working on needs to get stopped. It was really, leaving people with headaches at the end of the week. On top of that, ultimately our stakeholders, and especially our client, is happier. They're trusting the system is going to be up, and in emergency, they know our operations team, our developers are going to be on top of the situation. And so ultimately in practice, this has helped us to have goodwill for additional ideas, and the client trusts us to help guide them to the best solution. And so with this bit of function, our team, those split between a variety of needs and skills, really came together. And we've built out not just a working system, but a needed one. We've pushed forward each month, we've learned, and we've understood how to design an application as a team. We've gotten used to accepting and taking feedback, from clients and teammates, and we've learned how to work towards, realistic milestones. And, this progress has really impacted me. This is the first application I've led where I've had a team under me. I've built some things solo, but it's really amazing how far you're able to go when you have a team, much further than I've ever been able to take an application, a tool, alone in the same amount of time. I hope, each one of you, as you take on with your day, as you take on with your life, you look around at your workplace and you find ways to improve it. If not solely for yourself, in, that selfish way of wanting to have good things, but also for providing for your teammates. And so, I hope you have a great rest of your day. Hope you enjoy lunch. Thanks again for coming to this talk. I wish each of you a great, rest of your DevOps days 2021. And thanks for stopping by.